This video is on the objective: perform and interpret a hypothesis test for the mean, population mean, with the population standard deviation known. All right, so that means sigma is known, and that means that our test statistic and critical values, if we're looking at them, will be z-scores, right? We're working with the standard normal distribution. This is using technology, right? Using a calculator. I'm going to be going over this with my TI-84 Plus. If you have a TI-83, 84, it's pretty similar, right? Very similar functions. And this is number one, the first video on this, on a problem related to this objective in your Newton Alta homework. So let's take a look. So if you want to see some, how they're going to instruct you how to do this with a calculator, click on More Instruction. Look at their videos, their instruction, their notes, their examples. Hopefully those help. All right. So now this is going to be through, they're taking you through all the steps of a hypothesis test here. So setting up your hypotheses, what's your significance level, what's the test statistic, p-value, and that's the thing about your calculator. Your calculator will give you a p-value for a test statistic. It'll also give you the test statistic right away. So you'll see that it's going to be pretty quick and easy to work a one mean hypothesis test where the population standard deviation is known. It's going to be pretty easy to do that kind of a test on your calculator. All right, so here a hospital administrator noticed a large change in the weight of babies being born at the hospital in the last few months. So she randomly selected 10 babies born in the last month. Historically, right, so going back with previous data, babies at the hospital had a mean weight of 7.63 pounds and a standard deviation of 1.02 pounds. So this is like mu and sigma right now. To test the weights, the administrator decided to use the historical standard deviation as the population standard deviation. All right, so again, sigma is known to be 1.02. The hospital administrator conducts a one mean hypothesis test, the word test should be there, at the 5% significance level, right? That's the value of alpha, to test if the change in weight of babies being born at the hospital in the last few months from 7.63 pounds. So she's testing if there's a change in this mean weight. So the null hypothesis will be the mean weight is 7.63 pounds for all the babies at this hospital being born. And then the alternative hypothesis, which will be the claim, what's being tested, is that there's a change in the weight, a different weight, so that the mean is not 7.63 pounds. So if you look at the null hypothesis and alternative hypothesis choices, the only one that makes any sense here is the fourth one. All right. Again, the null hypothesis, what's being assumed is that the weight is 7.63 pounds, the mean weight. And the alternative, what's being tested, is that the mean weight is changed, is not 7.63 pounds. And this will be a two-tailed test. And again, read through the answer explanations. Now there should be more to this because we're going to be completing a full hypothesis test here. All right, and there is. So notice here, same question. So now, here's this sample she took of 10 babies. So it's weights in pounds of babies born. The sample of 10 babies she took from the past few months is given below. It says to use our calculator to test whether the mean weight of babies born at the hospital in the last month is different than the historic average of 7.63 pounds. Identify the test statistic, write the z-score for this sample mean, and the p-value from the calculator output and rounding to 2 decimal places. So again, here I'm given now on the calculator, I'm given this sample. Here's 10 10 babies' weights from the past month. So I'll pull up the calculator, and we're going to enter, this sample of 10 baby weights in a list. Hopefully you recall how to do that, right? Go Stat, Edit, and then I'll just do this down L1, down list 1, right? So one baby weighed 6.3 pounds that she sampled, and 8.2, 7.4, 7.1, 7.5, 6.7, 9.2. I'm sure you'll be able to enter it much faster. I got this, this emulator here. I have to click all the time. 7.8, and the 10th baby 6.06 pounds. Okay. So now I got this list of data, this sample. Let's get out of here, quit. And now we're going to perform a test about the population mean, a one mean test where the population standard deviation is known, right? Sigma is known here. So remember how we did remember how you did confidence intervals? All the hypothesis tests are in the same area. You hit stat, hit the stat button, and go over to where it says tests. And then the very top, see it says z-test. This is the test we're running with one population mean. When the population standard deviation is known, when sigma is known, you're working with z-scores. We'll see later, the one below it, t-test, is when the population standard deviation's not known, right? When sigma's unknown. You're working with the student's t-distribution. But right now we're working with z-scores, the normal distribution. So I just hit enter on number 1, z-test. Now, here in this particular example, I'm actually given a list of data, right? These 10 baby weights. Now, if I wasn't, I'd just go over to statistics. If I was given the sample mean and the size of the sample and that was it, I'd go to stats. But I was given data, so I stick to the data area. Now, this first part, you see mu 0. Remember how the null hypothesis, see how the null hypothesis is labeled H0? So this mu 0 is what's the population mean that you're assuming from the null hypothesis. So remember, we're assuming that the population mean for the baby weights is 7.63. That's the mean from the null hypothesis. That's what mu is. Then what is sigma? See, what is the population standard deviation? And again, we were told back in the problem that it was 1.02, right? Standard deviation of 1.02 for the previous population. So I enter 1.02 there. All right, then for list, this was, what list did you put this sample in? Right, these 10 baby weights, and it's already L1. Now, if you put it in a different list, just hit the second button, go 2 for L2, 3 for L3, and so on. But I already have L1. And then you have a frequency list. Now, there was no frequency list here. There was no probability list, or relative frequency. So I'll just leave that as 1, because each one of these babies was counted one time. And then you have, what kind of a test is it? Is it a two-tailed test, a left-tailed test, or a right-tailed test? Now, we saw from the alternative hypothesis is that mu is not equal, is different. There's a change from 7.63. So I'm going to keep it on the not equal to mu 0. Mu 0 up here is 7.63. So this is mu is not equal to 7.63. This line here is just how does the alternative hypothesis look? And then I calculate. And look what comes up. Right? Up top is the alternate hypothesis, the claim. The top is the alternative hypothesis or the claim. Then right beneath that, the second line, you see it's z equals. That's the test statistic. That's the z-score for the sample mean. Now the sample mean, those 10 babies, have an average weight of 7.2 pounds, and the standard deviation for that sample is 1.05, And you see the sample size is 10, n equals 10. But what's important here, you got the test statistic, the z-score for this sample mean is negative 1.33. And that's what I'm going to enter here. They said round to 2 decimal places. So test statistic, negative 1.33. And then right next to that, the p-value, which on the calculator display is the third line down. You see where it says p equals. P equals, this is that area to the left of the z-score doubled, right? Because it's a two-tailed test. 0.182, so 0.18. Right? They said round to 2 decimal places. The p-value, 0.18. And that's it. And then we're going to compare that p-value to the significance level. Right? The significance level is 5%. See how the p-value is 18%. The p-value is greater than alpha. And when the p-value is greater than alpha, you don't reject the null hypothesis. So we're going to keep the null hypothesis. We're going to stay saying that the mean weight is 7.63 pounds. And we're going to we're not going to support the claim. We're not going to support this statement that the mean is different from 7.63 pounds. All right, so that'll all come up here in a second. So let me pull the calculator down. See how very easy that is, right? Just entering information on your calculator. All right, so I'll submit. Great. Again, read through how they're doing it here. And then I'm sure they'll have one more part where we have to make a conclusion. All right. So now all that apply. Now, like I said, the p-value is greater than the significance level. 0.18 is greater than 0.05. If that is the case, we do not reject the null hypothesis. And if we're not rejecting it, we're keeping it. We're going to say the mean is 7.63, meaning we're not going to accept, we're not going to support the alternative hypothesis or the claim that the mean is not 7.63 or that the mean has changed. So one of these here. So let's read this first one. So if we don't reject the null, it means at the 5% significance level, the data provide enough evidence to conclude that the average weight of babies at the hospital changed. No, it didn't. We're saying it's not changing. We're keeping the null. So it's this last one. At the 5% significance level, the data do not provide enough evidence to conclude that the average weight changed. We're not supporting that. So we're going to say this last one. And again, that's because we didn't reject the null hypothesis. And I think that's all. Yeah, so they're going to have one more question after that. All right, so I'll come back with another video where I go through the calculator again. But hopefully watching me do it this first time helped when you go about doing it on your own. And thank you very much for watching.